So like the assignment said, I want to do an empirical formula problem with you to help you to see how it's done. This is not hard to do, but you will find that it's got a lot of little steps, and if you don't follow the steps in order, then it does not work out. So the problem we're going to solve today is a compound is 43.7% phosphorus and 56.3% oxygen. Calculate the empirical formula. What we want to find out is the subscript for the phosphorus and the subscript for the oxygen. So we are solving for X and we are solving for Y. So we're going to use this chart. If you use this chart every time you do these problems, it will make them a lot simpler. So the elements we are focused on are P and O. You could have more than two elements in the problem. The percentages are given in the problem. We have 43.7% phosphorus and 56.3% oxygen. Sometimes the questions will skip over this step and give you grams, so it saves you a step. If you do have percent, what you are doing is you are assuming that you have 100 grams of this sample. If I have 100 grams and 43.7% of it is phosphorus, that means that I have 43.7 grams. And if 56.3% of 100 grams is oxygen, then I have 56.3 grams of oxygen. The next thing we want to do, and you'll see that this part of the table is even bigger, and that is because we want to convert from grams to moles. So X moles equals 43.7 grams of phosphorus. I want to get rid of the grams of phosphorus. I want to turn it into moles of phosphorus. What am I going to use? I'm going to use the conversion factor that 1 mole of phosphorus is equal to its molar mass, and the molar mass of phosphorus is 30.97. Grams of phosphorus has canceled out. My answer is now in moles. I'm going to take 43.7, multiply it by 1, and then divide it by 30.97 to get 1.41 moles of phosphorus. I'm going to do the same thing with oxygen. X moles equals 56.3 grams of oxygen. I am going to put grams of oxygen on the bottom because I want to cancel them out, and I'm going to turn it into moles of oxygen. We know that 1 mole of oxygen equals the molar mass of oxygen, and that is 16.00 grams. Grams of oxygen cancels out. I now have moles of oxygen. 56.3 times 1 divided by 16 gives me 3.52 moles of oxygen. If you read the assignment 1 for this week, you will see that I said to you that we were going to make a connection between the moles and conversion work we were doing last week and the empirical and molecular formula, and here's the connection right here. Everything has to be in moles. The next step is to divide by the smallest number of moles. So I'm going to look at 1.41 moles of phosphorus and 3.52 moles. Which number is smaller, 1.41 or 3.52? 1.41 is smaller, so I'm going to divide both by 1.41. The reason I am doing that is because it forces one of my elements to have a subscript of 1. So 1.41 divided by 1.41 automatically gives me 1. 3.52 divided by 1.41 gives me 2.50. I'm going to tell you that the most common mistake at this point is people divide by the bigger number. So if you are getting a number less than 1 for either of your answers here, think about the math that you did and make sure you are dividing by the smallest. So you would see if we were to stop right here, our formula would be P1O 2.50. We know that chemical formulas do not exist as partial numbers. We don't have decimals in them. These have to both be whole numbers. So we want to multiply both the 1 and the 2.5. We have to do the same thing to everybody by a number such that the 2.5 becomes a whole number. So I'm going to take the 2.5 and I'm going to multiply it by 2, and that becomes 5. And I have to do the same thing to the 1, so I'm going to multiply it by 2, so it becomes 2. My formula is P2O5, and that is the empirical formula, the reduced formula of this substance.